Pioneer 10 and 11. These twin NASA probes were the original trailblazers. Pioneer 10 became the first spacecraft to traverse the asteroid belt, and Pioneer 11 followed soon after, building on that Pathfinder data on the way to Jupiter, and later Saturn. Their flybys of Jupiter provided humanity with its first-ever close-up images of the gas giant and its great red spot. Critically, their instruments measured Jupiter's intense radiation belts, providing the essential data that engineers needed to safely design all future missions to the planet. Voyager 1 and 2. The Voyager missions revolutionized our understanding of the Jupiter system. During their flybys in 1979, their advanced cameras revealed the planet's atmosphere to be a dynamic, chaotic place of swirling storms and intricate cloud features. But their greatest discoveries were at the moons. Voyager 1 captured the astonishing first images of active volcanoes erupting on Io, and both spacecraft returned data from Europa that provided the first tantalizing hints of a liquid water ocean beneath its icy shell. Ulysses. This was not a Jupiter mission, but a solar one that performed one of the most unique flybys in history. To study the poles of the Sun, the joint ESA and NASA Ulysses probe needed to leave the ecliptic, the flat plane where all the planets orbit. In 1992, it flew by Jupiter to use a gravity assist that dramatically tilted its trajectory out of the ecliptic, sending it into a high-inclination solar orbit over the Sun's poles. Galileo, the first spacecraft to ever orbit Jupiter. Arriving in 1995, Galileo was a two-part mission. It first deployed a small atmospheric probe, which became the first human-made object to plunge into Jupiter's atmosphere, transmitting data on its composition and structure before being destroyed. The main orbiter then spent 8 years conducting a detailed tour of the Jupiter system, with its primary focus on the Galilean moons. Its data provided the strongest evidence to date for the subsurface oceans on Europa, Ganymede, and Callisto. Cassini-Huygens. While on its primary mission to Saturn, the Cassini spacecraft performed a crucial flyby of Jupiter in late 2000 for a gravity assist. Its sophisticated instruments, more advanced than Galileo's, provided the most detailed global portrait of Jupiter's atmosphere at the time. It captured stunning images of storms and cloud dynamics and worked in tandem with the Galileo orbiter to study the planet's enormous magnetosphere from 2 different points simultaneously. New Horizons. On its way to Pluto, the New Horizons spacecraft flew past Jupiter in 2007, using the planet's gravity to shave 3 years off its journey time. The flyby was also a critical dress rehearsal to test its instruments. It returned spectacular high-resolution images of Jupiter's little red spot, tracked plumes from Io's volcanoes in unprecedented detail, and captured the clearest images yet of Jupiter's faint ring system. Juno, the first mission designed to study Jupiter's interior. Arriving in 2016, Juno's mission is not focused on the moons, but on understanding the origin and evolution of the planet itself. It flies in a unique, highly elliptical polar orbit that swoops low over the cloud tops and then swings far out into space to avoid the worst of Jupiter's radiation. Its instruments map Jupiter's magnetic and gravitational fields to determine the size and nature of its core, including whether it's compact or diluted, and to understand what drives the planet's deep atmospheric dynamics and storms. Next generation. The future of Jupiter exploration is defined by a new generation of highly advanced probes, with a laser focus on the tantalizing possibility of life in the oceans of its icy moons. This new era is led by the European Space Agency's JUICE, a mission that will conduct a grand tour of the system before achieving a historic first, entering into orbit around another planet's moon, Ganymede. Complementing this is NASA's Europa Clipper, a dedicated mission to investigate Europa's habitability by performing dozens of low-altitude flybys to confirm its subsurface ocean. Joining this international flotilla is China's ambitious Tianwen-4 mission. Planned for launch around 2029, it is a dual-probe mission that will send one spacecraft to study the Jupiter system, with the goal of eventually orbiting Callisto, while a second craft continues onward to Uranus. Together, these missions represent a new golden age of exploration focused on solving the mysteries of Jupiter's potentially life-bearing ocean worlds. Thanks for watching. Which Jupiter mission do you think changed our understanding of the planet the most? Let me know what you think in the comments. Also, please remember to like and subscribe if you enjoyed this video.